So now we're going to look at creating our first EC2 instance, which we've set up inside of test server. So now we've got test server over here. We've already done Terraform init. So now what we're going to do is basically get a few final things set up so that we can get ready to deploy this onto our AWS instance. So in order to do that, let's go into Terraform here and let's create another file, and we're going to call this file providers.tf. So now inside of this file here, we specify AWS as our sole provider, and we include the access key, so var AWS access key, and also the secret key as well. So secret key like that, and then region equals var.aws region, and then the version is going to be a tilde symbol greater than sign 2.0. So that's the one we're going to use, and save that. Now go back into terminal, type Terraform apply, and now you see it says 2 to add, 0 to change, 0 to destroy. So yours should be the same, and we have a AWS key pair and also an AWS instance. So now let's just click yes. So now that we've done that, it should say apply complete, resources 2 added, 0 changed, and 0 destroyed. So now let's go into Google Chrome here, and let's go back here and click on EC2. And inside of EC2, let's click on instances, and you notice that we have one instance of test server running, and we have a public DNS, and we also have an IPv4 public IP, and it should be running inside of the availability zone that you chose earlier. So my one here is in the region AP Southeast 2, and it's in the availability zone B, so that's AP Southeast 2B. Anyways, now let's grab this public IP here, and I'm going to try to SSH into this EC2 container. So basically SSH is secure shell. It allows you to essentially control this via the terminal. So now we've got Visual Studio Code here, and we have the key and also the pem. Now to remind you that the key is the private key here. So now inside of Terraform, we're going to do SSHI and then /microservices demo.key. Yeah, that's right. And then we do EC2 user @ and then we paste this in. We press enter, and it should not let us in. So this is the correct behavior. And the reason for this is because we have not set up the permissions to allow us to SSH into this container here. So in order to do that, let's first have a look at the most, I guess, basic way to do it, which is we're going to go into the actual AWS console and we're going to enable it manually. But in the future, we're going to look at doing this programmatically. So it's going to be pretty cool. Now down here, you notice we have security groups, we have default. So if we click on default here, it takes us to this page here, which is security groups. And if we deselect that, you notice that we also only have one. So now this one by default basically blocks all traffic, I'm pretty sure, so it only allows it from within that security group. But what we can actually do as a little fun thing to get this working is we click add rule and we add in SSH, and it's going to be a port range 22, so that's the SSH port, and we're going to allow it from your current IP address. So I'm going to just type in 0, actually I'm going to just choose anywhere here, so you can use my IP. In any case, we're going to revert this straight away, so you can just do this for now, click save. And once you do that, we should be able to go back into terminal, run that exact same command again, and then press enter, and it will say this, and we type yes, and it lets us in. So now we're inside our newly created EC2 container here. And what we're going to do is we're going to actually set up this container to include NVM, include Node, and include Yarn, and also some stuff for code deploy, which we're going to use later on. So now in order to do this, now you see if we were to type it in here, this would definitely be a manual process. Now the problem with it being a manual process is that that goes against the whole idea of Terraform here, because Terraform is meant to be infrastructure as code. So your whole infrastructure is meant to be able to be built directly from your code. But then if we start typing it in and doing commands manually, then that kind of defeats the purpose. So anyways, now that we're inside of here, let's just Control D to log back out, and let's go back to Google Chrome. Inside of inbound here, let's get rid of the SSH rules. So delete that, press save. Return that back to normal, and now we shouldn't be able to connect once again, so that's fine. But now what we're going to do is we're going to go into main.tf here, and we're going to write in something called user data. So user data specifically is a bunch of commands which are run when the instance is first created. So now let's go here, type in user data is equal to, and we're going to use this multi-line string syntax here. So we write something here and we write something there, and the first thing we're going to write is a shebang here, and then / bin, and then bash. So this basically tells it that it's going to be a bash script. And we're going to write this cd /tmp. So we're going to go into the temporary directory, and now we're going to write an echo And we're going to echo a bunch of stuff, and we're going to make that go into init.sh. So now the thing to understand here is that when we do the echo here, or when we do cdtmp, any of the commands here, they're all being run as root. Now that is problematic because when we actually do our deployment, a lot of the deployment is run as the normal user. So by having this bit of code here, I'll show you what it does, but we need to use the echo here. So anyways, inside of echo, we're going to do basically the same thing, so shebang bin bash like that, and we're going to write in a few commands. Now the first command we're going to use is the nvm. So if you go to nvm.sh and we copy the one for curl, so just this curl line here, so we can just copy that whole line and paste that here. So that will download and install nvm, and then we're going to do source home directory /.bashrc. Now you can see why it's really important to run this as the normal user, because if we were to run this as root, then obviously this would mean a different directory, and this will get installed with the wrong permissions, so on and so forth. So anyways, let's continue. So we do that. So now we can access nvm straight away. So nvm i 12.13.0 is the one we're going to use. And now let's do a similar thing for yarn. So let's go to yarnpkg.com, go to install yarn here. We're going to just click on alternatives here, I think, and we're just going to grab the installation script. So that's this line here. So that one there, so you can see, and grab this line, and we're going to paste it here. And then we're going to do sudo yum install -y. So this is one that we actually do want to run as a super user, and we use -y so that it installs automatically and it doesn't have to ask us for permission, because this is non-interactive. So we actually don't have the ability to say yes or no, even if we wanted to. So we have to say yes, and we install ruby and wget, and we go into cd /home ec2 user, and we're going to do these few lines here. Make sure you don't type these incorrectly. Wget https AWS code deploy ap southeast 2 S3 AP Southeast 2 Amazon AWS.com. So basically this bit here is an S3 bucket. So notice it says S3 and the bucket name is AWS Code Deploy AP Southeast 2. So this is one that's created by Amazon, and this allows us to basically get something called the code deploy agent working inside of EC2. So without the code deploy agent, we actually can't deploy code onto our EC2 container. So we do that. We add executable status to this file, which we just downloaded, so install, and then we run it with sudo, and we supply auto at the end. I'm not too sure what that does, but that's what we got here. And now we're going to do a whole bunch of symlinks. So first one is going to be sudo ln-s home ec2 user.nvm versions node. And notice the version number here, v12.13.0 /bin/node, and we're going to make this go into usr/bin. So this allows us to use node even as a super user, and you'll see why that's important later on. So now let's do a second one, and this one's going to be node here, version 12.13.0, bin and npm, usr bin like that. And let's do one more. This one's going to be sudo ln-s home ec2 user /.yarn/bin/yarn. Actually, one more note here. Instead of writing home ec2 user so many times, we probably could just do the tilde sign like that, because we're running this as the ec2 user. So anyways, now we've got that. Let's do /usr/bin, and then sudo yarn global add pm2. So we're going to add pm2 since we installed yarn up here, we can use it down here. PM2 is for managing processes. I'm going to show you more of that later on as well. We're going to do sudo ln-s and one more usr local /bin/pm2, which is where it installs by default. I want to move it into usr bin as well. So now that we've got that, we can put this bit here on the end to end off that line. And then now we're going to give this file here. So remember that all of this goes into a file called init.sh. And then we're going to add executable permissions to this file. So init.sh like that. And then we're going to do /bin/su-c double quotes /tmp /init.sh. Remember that this is inside of the /tmp directory. And then we're going to do ec2-user, and then we're going to do rm init.sh to remove the file at the very end when we're done. So this is a whole big mess of bash commands and all that kind of stuff, but this will essentially get Node.js set up, get npm set up, get yarn set up, and also get code deploy set up on our EC2 container. So now that you've got all of this, remove that semicolon there, that one's my bad. And now let's go back into terminal and make sure once again that you've typed it correctly. Let's do Terraform apply. So now, whilst that kind of does its thing, what it's doing is it's checking if there are any changes, and it's checking to see what it's going to need to do next. So now you notice it says plan 1 to add, 0 to change, 1 to destroy. So what's actually happening is the AWS instance must be replaced. And the reason for that is because we changed the user data. Now when the user data gets changed, we have to recreate it. So now let's do that, and let's type in yes here. So we'll let it recreate it. Okay, great. So now that that is done, we have our resource created. And if we go back into Google Chrome here, so now we have one that's terminated. This was our previous one. It's going to disappear pretty soon, so we don't have to worry about that. But this here is our new IP address. So if you actually grab this here, you'll notice that it's different to the one that we had before. So this is our new IP address for our instance. And if we want to access this, we have to go over into default here again. So inside security groups, go to inbound, edit, add a new rule. Let's add in SSH22 again for anywhere, click save. And now that we've done that, let's go into there. So SSHI and just paste in this after there. So we have our new IP address, type in yes, and now we're in. So now that we're in here, the best way to test if it actually did anything is do type node, type nvm, type yarn, and you see that all of those things are there, which is really cool because that now tells us that we can use code, only code, to get a full Node.js server running. So this is really nice and very promising. So now I'm going to show you how to delete Terraform instances. So now we currently have one created. So everything inside of here has currently been created in terms of a test server. And in addition to that test server, also key pairs, we have an AWS key pair as well. So if we want to delete all of this, actually, before we do that, let's go to key pairs here and let me show you where this one is located. So if we go over into Google Chrome, let's click on services again, type in IAM and just open this one in a new tab or something like that. So now if you want to find where the key pairs are, you just need to go down here to network and security, click on key pairs, and you notice we have Microservices demo key here. So now let's go back into terminal here and type in Terraform Destroy. So destroy will actually get rid of everything that we've created. It'll delete all of it from our AWS account. So now you see it says our plan is 0 to add, 0 to change, 2 to destroy. So it's going to destroy the AWS key pair and it's going to destroy the instance. So now we go here, enter a value, we type in yes, which allows us to do the destruction. Okay, so now that the destruction is done, we're going to go back into VS Code here and let's start adding in some more stuff. So we've currently got a Node server with main and variables, but what we're going to do is for the Node server, let's add in a new file and call this one outputs.tf. So an output is something which a function returns. You can kind of think of it that way. Obviously, it's not a function, it's a module here, but the concept is very similar. So we do output here and we're going to do instance ID. And then value equals AWS instance.default.id. Now, just to remind you, the AWS instance.default comes from main here, which is a resource AWS instance default. So that's this one here. We return the ID, and let's also return the name. So value equals var.name like that. And let's also return the private IP. So this will come in handy later, but let's do value equals AWS instance .default.private IP like so. So now we have these three outputs for our Node server. So now what we're going to do is go into Terraform here, create a new folder, and we're going to call this one MySQLDB. So this is going to be for our RDS MySQL databases, if you remember from the AWS architecture diagram, which I'm going to put up on the video right now. So now for this one here, go into MySQLDB and let's create a file called variables.tf once again. And inside of this file here, we're going to add quite a few things for this one because our MySQL database is quite configurable. So we're going to add in a variable, which is going to be apply immediately. And this one's going to be a type of Boolean, and the default value is going to be false. So apply immediately, we'll use this one later on in a configuration option with the same name, but with an underscore. It basically means that any changes we make to the database, if it's set to true, then they apply immediately. Now, the downside to that is that there might be some downtime. However, in our case here, because we're just kind of testing locally, for the sake of development, I actually turn this one to true. You can leave it as false in the final result when we get there, but this is one we need to have here. Let's also do a variable. And this one's going to be DB name. So the database name is going to be a string. Variable DB subnet group name. Once again, type equals string. Variable engine version. Type is going to be string. And the default value is going to be 5.7. So this is the version of MySQL that we're going to be using. Variable identifier. And this one's going to be type equals string. Variable instance class. If I can spell that correctly, curly braces like that. We do default equals db.t2.micro, and type is going to be string. So once again, this is the free tier, so that's the one we're using here. And now we do variable parameter group name, curly braces like that. Default equals default.mysql 5.7. Type is going to be string. Variable password. Type equals string. Variable publicly accessible. Type equals bool. So this one basically says, can the database be accessed publicly? And we also do variable username. Type equals string. And then variable VPC security group IDs. And you remember we kind of have the same one inside of Node server, but we haven't actually used it yet. So default is just an empty array. And then the type is going to be list string. So now we have all of these here. Let's create a new file, and we're going to call this one main.tf. So now for this file, we do resource AWS DB instance. So this is what we use inside of Terraform for a database. We're going to call this one default as well. Like I said, these names here are basically unique to Terraform, and they're only used internally. You'll notice that this one's called default, and so is this one. But in our case here, they're both inside of modules, and they're also in different resources. So having the same name here doesn't matter. We're going to do allocated storage is going to be 20. So 20 is the smallest amount of storage we can apply by default, basically 20 gigabytes. And that's what we're going to use here. Storage type is GP2. This is the data storage method that we use. There's GP2 and there's also another one. This is on the RDS documentation, as well as we can have a look at the actual website here as well. So under AWS here, if we go to RDS and we have a look inside of databases, we do create database. Let's choose MySQL here, and then let's go down a little bit, and you'll notice that we have storage type. So we have either provision IOPS or general purpose. So this is GP2. I don't know what this one here is called, but GP2 is a little bit cheaper. So that's the one I'm going to use here. This one's a little bit faster, but we don't need that here. So anyways, we use a GP2 for that one there. Engine is MySQL. So there are different database engines we can use, but in our case here, we're using MySQL because that's what we used locally as well. And now we're going to do apply immediately is equal to var.apply immediately like that. And then db subnet group name equals var db subnet group name like that. Engine version equals var.engine version. Identify equals var.identifier. Instance class is equal to var.instance class like that. Name equals var.db name. Parameter group name equals var.parameter group name there. Password equals var.password. Publicly accessible equals var.publicly accessible. Skip final snapshot. This one we're just going to set straight to true. So what this one here means is basically when you delete the database, are we going to keep a final snapshot of the database? And what I'm saying here is no, because we don't need that. That does also cost money. So we can just specify that like so. Username equals var.username, and then VPC security group IDs equals var.vpc security group IDs like that. So now we have main and we have variables. Let's create another file. I'm going to call this one outputs.tf. And for this one here, we only have one output, which is the address, and it's going to be value equals AWS DB instance.default.address. So this is the output from our MySQL DB. So now that we have these two here, let's go back into Terraform here, create a new file, and now we're going to start looking at doing the networking. So once again, in that diagram there, as you can see, we have a VPC, and we actually show 2 subnets, but what we're actually going to use is 3, but it gets a little bit complicated. Anyways, the idea here is we have these this VPC, which is a virtual private cloud. And you need to have one for every AWS account. And in our case here, we actually create a custom one and we do some stuff with that. So I'm going to show you how to do that here. So let's do networking.tf for our new file, which contains all of our networking stuff. So now for this file here, we're going to do resource AWS VPC, and we're going to call it Microservices demo. So this is going to be for the whole application. And we're going to do a CIDR block. So a CIDR block equals 10.0.0.0/16. So now before we go any further, let me grab this and let me show you what this actually means. So now we have a CIDR block calculator. Okay, so this one here, 10.0.0.0 and then 16. So now let's have a look at this one here. You'll notice that our IP address here is 10.0.0.0. If you know binary, you know that this number here means 0. This number here means 1. This number here in units is 2, 4, 8, 16, 32, 64, 128. So this one here is 0 plus 1 times 2, which is 2, plus 0 times 4, plus 1 times 8. So basically 2 plus 8 equals 10. So that's why we have this one here. This one's completely 0, completely 0, completely 0. Now, why are these two colored? Well, this number here is 16. So it goes from the very start and it grabs 16 bits. So basically what that means is that these 16 bits are not going to change, whereas these bits can change however they want. So what it means is that we actually have 2 to the power of 16 because 32 in total. We take 16 of them and we set them in stone. So the other 16 can either be 0 or 1. So that gives us a total possibility of 65,536 different IP addresses. So this is our VPC. And by having that many IP addresses, we can have, a crazy number of databases, EC2 instances, all that kind of good stuff. And this is what we use for our VPC. So that's what the CIDR does here. It's important to note that this CIDR block is completely private. So this is not an IP address range which can be accessed on the internet, but instead this is just something local, which we use inside of our VPC. So the VPC itself probably has some sort of IP address as well, but that would probably be a public IP. In this case here, this refers strictly to a private IP. So we do that, and we're also going to do enable DNS host names to be equal to true. So if we don't do this, we actually can't access the contents of the VPC over the internet. So we have that there. And for tags, we do name equals microservices, if I can spell that, demo VPC like that. So this is going to be our VPC for our microservices demo. So now, in addition to this, let's go on top of it and let's create resource AWS subnet. And this one's going to be microservices demo subnet public. So this is going to be our public subnet, and it's going to have an availability zone of APSE2-AZ1. So now APSE2 stands for AP Southeast 2 hyphen AZ1 means availability zone 1. So you can change this to what you need depending on your region. So we have availability zone ID like that. And now our CIDR block is going to be 10.0.0.0/24. So now notice how this one's 16 and this one's 24. So this means that this actually is a subset of this one here, because this one has 10.0 as static and these can be whatever they want. But this one here has 10.0.0 as static. So basically it means that this subnet is also a subset of the private IP addresses that are created by the VPC. So we have that here, and we also have VPC ID equals to AWS VPC.microservicesdemo.id. So this is going to mean that our subnet is associated with our VPC. So now we do our tags as well. Let's add in a name. So this one's going to be microservices demo subnet, and it's going to be public. So this is our public subnet. Now let's grab this and let's duplicate it once, and let's duplicate it one more time. And this one here is going to be private-1. So we're going to actually have two private subnets, and I'm going to explain why in just a second here. But for the CIDR block, we have to change it so that it's unique to this one here. Remember that all of the first 24 bits are taken. So basically these three numbers here. So our one here has to be unique. So we use 10.0.1.0. And then now for this one here, we're going to do private2. And this one's going to be 10.0.2.0. So now we have that one there like so. And for our availability zones, this one's going to be AZ1 as well, but this one we're going to change to AZ2. So now we have availability zone 1, 1, and 2 here, and the CIDR block has changed. Now for the names, we're going to rename this one. Both of them to private. This one's private1, this one is private2. So now that we have these ones set up, let's go up to the top here and let's add in something called an AWS DB subnet group. So we have to do resource here like that, AWS DB subnet group, and we're going to call this one private. So this is our private DB subnet group. Both of our databases in the architectural diagram are inside of private subnets, so they're not meant to be accessed directly from the internet. So we can just call it private here. We're going to do name equals microservices demo DB subnet group private like that. So now that we have that, we do subnet IDs is equal to AWS subnet dot microservices demo subnet private 1 dot ID. So the first private one, and then AWS subnet dot microservices demo subnet private 2 .id. So we have those two there. This is why we have two private subnets, because when you have a database subnet group, it has to be on two subnets spanning two availability zones. So this one here is on AZ1, this one's on AZ2. So it has to be on two separate availability zones with two different subnets, which is why we do this here. So anyways, now we go here, do tags equals name equals private DB subnet group. So give it a name there as well. And we're going to add here an internet gateway. So resource AWS internet gateway and this one's going to be called Microservices Demo. The Internet Gateway allows us to access the internet, so this is going to be part of the stuff we use inside a public. So we do VPC ID equals AWS VPC .microservicesdemo.id. So we basically, everything here is connected to that VPC in some way or another.